Welcome to The Explainer. Today, we are completely transforming your study session. I want you to imagine we are stepping out of the classroom and straight into a high-stakes corporate boardroom. Imagine you are pitching your exam answers directly to a board of directors. And in this scenario, that board of directors, they are the Cambridge Principal Examiners. If you want to master the Cambridge AS and A-Level Computer Science 9618 syllabus and truly understand its foundational frameworks, you cannot just walk in and drop a bunch of memorized facts on the table. It just doesn't work that way. You have to justify every single point with hard data and clear strategy. Throughout this explainer, we are going to build a completely foolproof, airtight system for answering the absolutely hardest questions on your paper. We're talking about guaranteeing maximum method marks and unlocking a level of deep analytical precision you might not even know you had. So get ready to upgrade your mindset. We are moving away from being a student just hoping to scrape by for points, and we are stepping into the role of an executive demanding top marks. Let's get into it. I really want you to look closely at this quote on the screen. This is pulled directly from the Cambridge Principal Examiner Report. When the exact people who are writing and grading your exams explicitly come out and state that data validation methods, and specifically the subtle distinction between a presence check and an existence check, is, quote, one of the most misunderstood areas in computer science, well, we need to stop everything and pay close attention. The stakes are incredibly high here. Every single year, thousands upon thousands of students throw away easy, guaranteed marks because they are relying on superficial rote memorization. They memorize a textbook definition instead of deeply understanding the underlying algorithmic logic required to actually solve the problem. But don't worry, because this explainer is going to completely fix that for you. We are going to decode exactly what the examiners are desperately looking for and will ensure you never lose these crucial marks ever again. Here is our strategic roadmap for today's session. We'll start with the validation dilemma, move into core principles, lay out the procedural framework, run an algorithm evaluation workshop, and wrap up with critical examiner warnings. Let's systematically conquer this. Act 1. The validation dilemma. Let's break down the challenge of unfamiliar contexts. Okay, let's dive right into this dilemma. The absolute hardest part of the computer science paper isn't actually memorizing the definitions. It's applying those definitions to completely unfamiliar real-world context that you have literally never seen before. What happens when you open the exam paper and it throws you into a massively complex scenario? Maybe it's a hospital database system processing critical life-or-death patient records. Or maybe it's a global logistics company tracking thousands of shipping containers across the ocean. To see how students usually handle this kind of pressure, let's look at two incredibly common, yet deeply flawed approaches. On the left side here, we have Alex's answer. Now, Alex has memorized the entire textbook. He is a walking dictionary. But he overloads the page with raw facts about validation, data types, and system architecture, while providing absolutely zero analysis. He never actually connects those textbook facts to the specific hospital or shipping context. Then on the right side, we have Sam. Sam actually understands the core concept perfectly, but he rushes the structure. He completely ignores the specific command words in the prompt, like evaluate or analyze, which leaves his answer incredibly superficial. Here is the bottom line. Neither of these students hits the required cognitive domains of application and analysis. And because of that, both of them leave massive points on the table. So, it begs the crucial question, why do students find applying concepts to unfamiliar contexts so incredibly hard? It's largely because most students study purely for recognition, not for strategic implementation. To bridge that massive gap between simply knowing a fact and actually applying it in a high-pressure scenario, you need a highly structured, logical system that acts as your bridge. Before we continue and reveal exactly what that system is, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Make sure you click that subscribe button and hit the bell icon right now so you don't miss out on these strategies. Act 2. Core Principles. It is time to start decoding the commands. You have to understand that academic benchmarks in the Cambridge system heavily prioritize analytical depth over superficial breadth. Going back to our boardroom metaphor, an executive doesn't just want you to read a list of product features, they want to know exactly how those features solve the specific problem at hand. And this brings us to a massive examiner alert. The conceptual framework for data validation frequently trips students up right here on these two terms. A presence check simply verifies that data has actually been entered into a field. Think about it. Did the user leave the text box completely blank, or did they actually type something? That is literally it. It just checks if something is present. An existence check, however, is a much more complex algorithmic process. It verifies that the entered data currently exists within a system or a backend database. For example, let's say you're on a login screen. A presence check simply ensures you didn't leave the username field empty. But an existence check, that takes what you typed, searches the backend database, and ensures that the username actually belongs to a registered, active account. Confusing these two distinct concepts in an extended response will instantly cap your marks. So the golden rule here is to always define your terms clearly before applying them to the exam's context. Now, to prevent yourself from making those conceptual errors under pressure, you need a rigorous writing structure. Enter the Peel framework. Point, evidence, explanation, and link. This is absolutely the gold standard for structuring top-tier computer science answers. Let's break it down. First, make your point clearly and concisely. Second, provide evidence pulled directly from the specific scenario given in the exam question. Don't just invent something, use their context. Third, write your explanation. This is where you detail the algorithmic or technical reasoning, and this is exactly where your deep syllabus knowledge shines. Finally, provide the link. You have to tie your entire argument right back to the original command word of the question. If you pitch your exam answers using this precise Peel structure, the examiners literally cannot deny your marks. It forces you to be analytical. So, the crucial takeaway here is understanding the method mark strategy. In Cambridge Computer Science, just magically arriving at the final answer is rarely enough to get full credit. Examiners explicitly award marks for your systematic process, your evidence-based reasoning, and your incredibly clear documented working. They genuinely want to see the logical journey you took to arrive at your conclusion. If a question asks for a solution and you just scribble down, use an existence check, you might get one measly mark for identifying the concept. But if you explain the algorithmic steps required to actually query that database, if you mention how to handle potential edge cases, and if you explain how the system returns a Boolean validation state based on the result, well, that is how you secure the maximum method marks available. You have to show them how your brain works. Act 3, the procedural framework. Let's watch the transformation happen. We're now going to take those flawed, red-inked answers from students like Alex and Sam, and we're going to transform them into perfect green check marks. To do this consistently, especially when the clock is ticking down and you are under immense time pressure, you cannot just sit there and rely on a sudden burst of inspiration. You have to rely on a standardized, battle-tested procedure. Here is the exact 5-step procedural sequence pulled directly from our technical methodology source. Step 1. Deconstruct the question. Literally take your pen and underline the command words and the context. Step 2, extract relevant data. Ask yourself, what are the strict constraints of the system described in the prompt? Step 3, select your analytical framework. Figure out if you're comparing time complexities, or evaluating validation methods, or something else entirely. Step 4, execute with clear notation. Write your pseudocode or your logical arguments with absolute precision. No sloppy syntax. Step 5, present in an appropriate format. Use the exact correct terminology, use bullet points if it helps clarity, or use structured paragraphs as required. Following this exact blueprint is how you guarantee maximum method marks every single time. Seriously, stop right there and let this sink in. If you master these exact strategies, combining the Peel framework with this rigorous 5-step blueprint we just covered, you are looking at a potential improvement of 2 to 3 full grade boundaries. This isn't about spending hours memorizing more random facts. It's about building an airtight analytical system that works for you every single time you sit down for a paper. Stop scrolling. Subscribe to our YouTube channel, AC Exams, at acexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve, and you can join them right now by subscribing and turning on all notifications so you never miss our weekly exam strategy sessions. All right, getting back to our framework, let's look at the chronological algorithmic thinking process that is absolutely required for practical applications in the 9618 syllabus. Step 1 is decomposition. This means taking a massive, overwhelming validation problem and breaking it down into much smaller, manageable subroutines. Step 2 is data structure selection. This is where you make the critical executive decision of whether a simple array, a dynamic linked list, or a complex hash table is the best choice for your specific existence check lookup. Step 3 is efficient implementation. This means sitting down and writing the actual code or pseudocode as cleanly and efficiently as possible. And finally, step 4 is rigorous testing. You cannot skip this. You have to systematically run normal, abnormal, and extreme data through your algorithm on paper to definitively prove to the examiner that it works under all conditions. Act 4, algorithm evaluation.
Welcome to the interactive workshop portion of our masterclass. It is one thing to sit back and hear the theory, but when you're in the boardroom, when you're sitting in that exam hall, you have to perform under immense pressure. When you are asked to evaluate an algorithm's quality, you must instantly recognize its efficiency, its resource management, and its potential failure points. So, we are going to put your data interpretation skills to the test right now. You have 60 seconds on the clock. I want you to imagine a highly complex data table on your screen right now. It's showing the performance metrics of a sequential search existence check up against a binary search existence check, and they are both running over a massive data set of 1 million records. Your challenge is to quickly scan that data and extract the core trend. What exactly happens to the time complexity as that data set scales up to 1 million? If you are actively applying the principles we've discussed today, you should instantly recognize that the sequential search degrades linearly. It takes way too long. Meanwhile, the binary search scales logarithmically, cutting the search space in half every time. Being able to extract that specific trend quickly without panicking is the exact data interpretation skill required to conquer this paper.
And this brilliantly illustrates the absolute foundation of critical analysis. When a Cambridge command word specifically asks you to compare or evaluate, you cannot just write two completely separate isolated paragraphs about two different things and hope the examiner connects the dots. Critical analysis actually requires identifying both similarities and differences in a connected way. Look at the table here. You must use comparative connectives. I'm talking about words like whereas, similarly, or in contrast. And most importantly, every single comparison you make must be supported by hard evidence extracted directly from the scenario. You cannot just broadly say one validation method is faster than another. You must prove why it is faster based on the specific data structure and the specific context provided in the prompt.
To make sure your critical analysis is completely bulletproof, I want you to use this evaluative thinking checklist. Memorize this. This is exactly what separates the top-scoring candidates from the rest of the pack. First, consider multiple solutions. Don't just stubbornly settle for the very first validation method that pops into your head. Second, analyze the trade-offs. Yes, an existence check is much more thorough than a simple presence check, but trade-off is that it takes significantly more processing power and time to query the database. Third, acknowledge limitations. What are the specific edge cases where your proposed algorithm might actually fail or crash? Be honest about it. Finally, justify all of your decisions with hard evidence. If you can confidently hit all 4 of these bullet points, your algorithmic evaluation will be completely flawless in the eyes of the examiner. Act 5, Examiner Warnings. This is where we lock in the final system.
Consider this your ultimate examiner's playbook. We have reviewed the winning strategies, but now we must confront the pitfalls that destroy grades. Even advanced students who perfectly understand the Peel framework and algorithmic decomposition can lose entire letter grades if they blindly fall into the traps that examiners see year after year. Now, what is really interesting about this slide is that every single one of these mistakes is entirely preventable. Here are the top 3 mistakes pulled directly from the principal examiner reports. Number 1, confusing cause and effect. Students very often describe the error message a system outputs, which is just the effect, rather than explaining the underlying validation logic that triggered it, which is the actual cause. Number 2, forgetting boundary conditions and edge cases. When you are writing out how you would test an algorithm, you must explicitly mention testing the absolute extreme limits of acceptable data, not just the normal inputs. And number 3, answers are not specific to the given context. This is a big one. If the exam question is specifically about a self-driving car sensor data, and you write a generic, memorized answer about password validation on a website, you will score 0 marks for application. You have to adapt to their scenario.
To actively combat these mistakes, we implement our ultimate 3-rule answering system. This is the whole explainer brought together. Rule 1, command word decoding. The absolute very second you open that exam paper, identify exactly what the cognitive demand of the question is. Are you analyzing, evaluating, or just stating? Rule 2, Peel framework application. Structure your thoughts methodically so that your main point is always backed by real evidence, detailed explanation, and a direct, clear link back to the scenario's context. Rule 3, time management matrix. Allocate your exam time strictly based on the mark weighting of the question. Please, do not spend 10 minutes writing a beautiful complex paragraph for a question that is only worth 2 marks. It ruins your pacing for the rest of the paper.
Before we finish up, here is a highly effective, actionable memory hack to ensure all of these theoretical foundations actually stick with you long after this explainer ends. Create a custom mnemonic using the first letters of the key data validation terms we've discussed today. For example, you already use Peel to easily remember your writing structure, right? So invent your own fun or weird acronym for data structure selection. By linking these complex algorithmic concepts to a simple, memorable trigger, you drastically reduce your cognitive load during the actual exam. That means you aren't stressing about remembering facts, freeing up your brain power for the deep analysis and application that actually scores the big points. Look at this number. This is the number that truly matters. Students who implement these specific computer science strategies see an average improvement of 2 full grade boundaries. Let that sink in. But, and this is a massive but, that only happens if they practice consistently. You can't just watch this and do nothing. Don't let another exam season pass you by. Hardwire these methods into your daily study routine. Consistent, highly structured practice is the only way to transform these theories into boardroom-ready execution. And remember, subscribe to our YouTube channel, AC Exams, at acetheexams_IGCS to excel in your Cambridge examinations. I want to hear from you now. Drop a comment down below with your target grade for 9618 Computer Science and tell me the biggest challenge you are currently facing in your prep. Our team reads every single one. Remember, take these frameworks, apply them strictly to past papers, and practice relentlessly before our next session together. Keep your answers perfectly structured, keep your analysis incredibly deep, and I will see you next time.